Hi, I'm George, and this week we're going to have a look at what we did with Lumpy. Now, Lumpy was that rocket that bent a few months ago at Thunder Down Under. So let's have a look what we did to it. So what do you do with a bent water rocket? You can't straighten it out, no matter how hard you try, but you can recycle it. Since we're rebuilding the Horizon Sustainer, we can save machining time by reusing the aluminium nozzle. We start by cutting it off the rocket with a hacksaw. Then we heat up the carbon fibre composite, since we know it goes soft with heat. And then whack it to separate the nozzle from the composite. This was also a good test to know how well the nozzle is secured, since the rocket always lands on the nozzle when it lands under parachute. From how hard we needed to hit it, we learned that there is no issue with the nozzle coming loose on landing. Here we're removing the fiberglass that covered the inner surface of the nozzle. Then we carefully use a Dremel to separate the composite. And here it is ready to go into Charlie. Next, we wanted to get an idea of what the pressure chamber looks like in cross-section, since that's something we never get to see with our rockets. We wanted to learn how well the pressure chamber goes together and what kind of voids there might be in it. So we cut off the top section of Lumpy. We used a hacksaw to then cut through the top part and the Dremel to split it in two. A half then gets sanded and polished so we can see it in detail. To get a real close look, rather than using a camera, we use a normal scanner to get about a 20 times magnification of the cross section. Okay, so let's have a look at the cross section. Here's the scan, and let's zoom in. We can have a look at the detail. So maybe let's start at the top. Here's the white PVC pipe that we use to hold the pressure chamber while we're working on it, and it also ends up being the anchor point for the shock cord. Down here, this is the 3D printed plug that plugs the hole, and you can see the actual individual layers here. They're about 0.2 millimeters thick, and you can also see the layers along the side here, and that was just epoxied in place. On the outside here, we've got the carbon fiber sleeves. In here is the 3K sleeve, and on the outside is the 12K sleeve. Down here, those white layers are the actual fiberglass reinforcements that we put inside to help support that plug. This right here is the epoxy that had pooled at the bottom of the end cap when we had it upside down when we were making it. Over here, you can also see these little bumps here, these little points. This is where we had the wire wrapped around the pressure chamber when it was being made. These are about 0.2 of a millimeter thick. So one of the things that we've been looking at during this cross-section inspection was how many voids we have between the different layers to see if there's little air pockets. And so far it's looked pretty good. If we have a look over here, this is the outer ring that holds the deployment mechanism. And down here you see a bit of a discoloration. This is the actual 5-minute epoxy that we use to tack these in place. And when that's cured, then we put on epi glue, and that's what these sections are over here and over here. And that hold the bulk of it. There is a few air pockets in here, but because they're outside of the pressure chamber, that's not a problem at all. So let's keep scrolling down. So this section here, this is the actual inner liner tube. Then on the inside, we have the end cap 3K sleeve. This is also the 3K sleeve. And then on that inside is that fiberglass reinforcement. This white wedge over here is epoxy with micro balloons. And this is what we use to fill in this step. Otherwise, if we didn't have that, the outer sleeve would create a void in here, which is not desirable. So this gives it a nice smooth finish. So we can scroll a bit further down. Let's zoom out to get a bit of context. So this is where the end cap goes to. Now, These bumps either side is actual epoxy that was pushed ahead of the end cap when we pushed that into the inner sleeve. And so one of the things we wanted to see is how clean that bead is, and that looks very nice. Because the pressure chamber goes on the rotisserie, that helps to avoid any runs or any unevenness. So that turned out really good. Looking further down the pressure chamber, all the way down here, we can see some voids between the inner liner, that you can see that separation there, that's that line, and the outer sleeve. So these would have been right at the bottom of the outer sleeve. Again, no problem, there's no voids that are going through, and that looks pretty clean. And you can see it in great detail on the other side, the difference between them. So the inner sleeve is, the inner line is about 0.6, 0.7 millimeters, and the average wall thickness we've measured is about 1.9. Again, you can see there's a little pocket of air there, but overall it looks pretty clean. Up here you can even see the 85 GSM fiberglass cloth that was wrapped over that inner liner. Those are those white fibers in here. And again, here you can see that white wedge. So overall it looks pretty clean. Here's a bit of a void. Again, that was when we were pushing the epi glue in. Not a big deal, it's about 1 millimeter in size. Again, well outside of the pressure chamber, so that's not an issue. Over here you can see the threaded hole. This is an M3 hole. This is what mounts the deployment mechanism. That screw goes in there. So yeah, so that's pretty much it. A tour of the cross section of the pressure chambers that we make. Okay, so what do we do with the rest of the rocket? Well, we can cut off the bent section for a start. We don't need that anymore. We can't use it as a pressure chamber, but we do have a tube with a nice set of fins attached to it, so we might as well turn it into a high power rocket. We start off by squaring up the base of the rocket. We then machine up a couple of centering rings. These are just made out of plywood. We already had a fiberglass tube left over from Light Shadow, and so we can use that as the motor mount tube. We glue the centering rings to the tube and let it cure. The next day we glue the motor tube into the rest of the body. Because of the taper at the bottom of the rocket, we need to insert the motor tube with the centering rings from the other side and push it all the way down. We cut a set of notches in the first ring so that it doesn't scrape away all the glue for the other ring. We want the tube to poke out about 5 millimeters from the bottom, so we can glue another centering ring from the outside. We put it on the rotisserie for a couple of hours to make sure that the glue is spread evenly. After those couple of hours, I took it off the rotisserie and stood it upright to cure overnight. The next day when I checked on it, this is what I found. The tube had slid down under its own weight. It was about 3 centimeters below the end of the rocket. It was still on center and it still would support the motor just fine, and so we left it as is. Next we machined up a thrust ring out of G10 fiberglass. Now this was going to transfer the thrust from the motor to the airframe. This was then glued to the very end of the rocket. Later we put some epi-glue around the edges as well to support it better. We had the option of using the motor ejection charge for parachute deployment, but we decided to go with the horizon deployment mechanism instead, since we already had one of those and it was the right size for this airframe. So we machined up a bulkhead from 10mm plywood. And then drilled a couple of holes in it for the shock cord mount. We glued it to the bottom of a short length of PVC pipe. This is the same pipe that the mandrel's made from. Then we put a loop of nylon cord through the bulkhead and tied it off. This is what will attach the shock cord. The whole thing then gets glued into the top of the airframe. And any excess epoxy gets wiped off. Now it's a simple matter of drilling and tapping a few holes in the PVC ring to mount the deployment mechanism. Lastly, we drill a small hole in the thrust ring and tap that hole for an M3 thread. We put extra epi glue in this section for better support. And then we made a small steel bracket as the motor retainer. The rocket won't use the motor ejection charge, so it won't experience the normal ejection charge recoil, and so the retainer can be fairly simple. This is how the motor fits in. Just like in Light Shadow, we are using a cardboard liner between the motor and the motor tube. And the rocket is now ready for flight. So there you go, Lumpy lives on. Now we hope to fly it in about a week's time at Malele at our high power launch site. We're going to fly it on an H110 motor, and with that flight we'll put together a video again for you to see. Anyway, that's all for this week. Thanks for watching, and we'll see you next time. Mm-hmm.